So I would like to graph one more function. This one involves one additional piece of information that we have not looked at before. So here we'll deal with f of x equals x squared minus 5x minus 6 over x squared minus 36. So I'll start from the top. I'll find my domain, which requires me to examine the denominator. When is x squared minus 36 equal to 0? Well, we can solve this by the square root method. We can say x squared would be equal to 36. So x is the positive or negative square root of 36. In other words, x is positive or negative 6. So those are the x values we want to watch out for. So we could say our domain is negative infinity to negative 6, skipping negative 6, everything in between those two x values, and everything past positive 6. Alright, so now we want to simplify our function. Remember, step 2 of that procedure is always to reduce the function down. So we can say f of x is, if we factor the numerator, it'll factor as x minus 6, x plus 1. And our denominator, you'll notice, is a difference of squares. So if I think of this as x squared minus 6 squared, I can factor this as x plus 6 times x minus 6. And then I can see how the x minus 6 terms will cancel, and I'll just be left with x plus 1 over x plus 6. So this is the factored and reduced form of our function, and we'll be using this from here on in. So let's look at the intercepts. We'll look at the y-intercept first. If x is 0, now I'm going to use the reduced form of my function. So 0 plus 1 over 0 plus 6. So that's a lot nicer than using the original. I get 1/6. So we've got a y-intercept at 1 over 6. And for our x-intercepts, we will set our function equal to 0 and multiply both sides by the denominator to clear out the fractions. So 0 times x plus 6 equals x plus 1, and the left-hand side is really just a complicated way of saying 0. So if 0 equals x plus 1, it seems that x must be negative 1. That's our x-intercept and our only x-intercept. And we can now look at the asymptotes. So our vertical asymptote, remember the vertical asymptote, this is the first time where we've actually been able to reduce our function. So our vertical asymptote is going to come from the denominator of the reduced form. So we set that equal to 0, and we see that x equals negative 6 is our asymptote. And we only have one in the case of this function. Then our horizontal asymptote, we can use either form that we want, but I'll use the simplified form, x plus 1 over x plus 6. If I compare the leading terms, I see they have the same degree. So our horizontal asymptote, we do have one, is at y equals the quotient of the coefficients. So y equals 1. And then I'll ask, does our function cross its horizontal asymptote? Remember, to solve that question, we set our asymptote equal to our function and say, does this ever work? So is 1 ever equal to x plus 1 over x plus 6? And again, you can use the reduced form. It's going to make life easier. And if I multiply both sides by the denominator, I see But this implies that x plus 6 equals x plus 1. Now if I try to solve this equation, maybe by moving my x's over, subtracting an x from the left side and necessarily subtracting 1 from the right, I see the equation 6 equals 1, which I know is false. So this tells me that they do not intersect. That's not true, so that's not true, so our original assumption must not be true.